Hello friends, now we will discuss about a very important concept of thermodynamics, that is Gibbs free energy, and Gibbs free energy is represented by G. Actually, Gibbs free energy G is equal to H minus Ts. What is G? G is the Gibbs free energy of the system. Mind it, system. This is very important. H is enthalpy of the system. T is absolute temperature of the system. S is entropy of the system. So, Gibbs free energy is the difference of enthalpy and product of absolute temperature and entropy of the system. Now, why this concept of Gibbs free energy is required? From the previous discussion, we know that for spontaneous process, delta S universe is greater than 0. Now, delta S universe means delta S system plus delta S surroundings. We can easily measure the delta S system, but delta S measuring of delta S surrounding is very difficult. So, a new concept is required called Gibbs free energy. Actually, if Gibbs free energy change, that is delta G of a system, is less than 0, the process is spontaneous. Now the study becomes very easy. Actually, if we measure the change of the Gibbs free energy of the system, we can measure whether the process is spontaneous or not. And if delta G system is equal to 0, the process is in equilibrium. So this is the thermodynamic criteria for spontaneity and equilibrium in terms of Gibbs free energy change. This is unique. If we measure only the Gibbs free energy change of the system, we can predict whether the process is spontaneous or not. This is very important concept. Now let us consider the characteristics of G. Characteristics of G. Number 1. It is an extensive property of the system. Number 2. Its change, that is dg, is a state function. That means the change of Gibbs free energy depends only on final state and initial state, but not on the path of transition. Now, actually we write a very important reaction called Gibbs helmholtz equation. The Gibbs helmholtz equation states that, what is Gibbs helmholtz equation? It is delta G equal to delta H minus T delta S. Mind it, delta G is change in Gibbs free energy for the system. Delta H is change of enthalpy of the system. T is the absolute temperature of the system, and delta S is the entropy change of the system. Now, we consider the following cases. Case 1, when delta H is negative, delta S is positive, delta G is always negative, and the process is spontaneous. Case 2. Delta H is negative, delta S is negative, but magnitude, that is mod value of delta H, is greater than mod value, that is magnitude of T delta S, then delta G is negative. Actually, we predict this from Gibbs-helmholtz equation, that is delta G equal to delta H minus T delta S. And delta G is negative, so the process is spontaneous. Case 3. Delta H is negative. Delta S is negative, but modulus of delta H is less than modulus of T delta S. In this case, delta G is positive and the process is non-spontaneous. Case 4. Delta H is positive. Delta S is positive, but modulus of delta H is greater than modulus of T delta S. So delta G become positive and the process is non-spontaneous. Number 5. Delta H is positive. Delta S is also positive, but modulus of delta H is less than modulus of T delta S. In this case, delta G is negative and the process is spontaneous. Last one, delta H is positive, delta S is negative, so delta G is always positive and the process is non-spontaneous. These are the very important features of Gibbs-helmholtz equation. With the help of Gibbs-helmholtz equation, we can predict whether a reaction is possible or not. This is the beauty of second law of thermodynamics and Gibbs free energy concept. That's all. Thank you. For testing your understanding of this lesson and more videos, log on to www.tubelessons.net.